Bon dia a tothom. El meu nom és Cecilio Angulo, soc el delegat del rector en temes d'IA, per tant, el que intenta fer una mica de pushing en tots aquests temes a la UPC, i supercontent i superhonorat de que estigui tan plena la classe, perquè això és una masterclass, per tant, que la classe estigui tan plena i que tinguem un professor tant de prestigi com l'Oriol Vinyals, d'acord? Ara, si podem dir, m'agrada presentar-ho com a professor de la UPC, d'acord? Des d'ahir. I en el seu temps lliure fa alguna cosa a Google DeepMind i coses per l'estil. Ahir jo no sabia que això de signar contractes era tan pompós, perquè ahir el van fitxar, diguem, a la UPC i van fer la investidura honoris causa i em vaig quedar, o volia intentar recordar per a aquests que no van poder venir ahir, tres conceptes que trobo que eren interessants o que a mi em van sobtar i que volia recalcar. La primera era donar les gràcies al CEFIS per aquesta forma de treballar amb elitisme però sense classisme. O sigui, tu pots identificar on hi ha el talent i tot i així mantenir-lo dintre d'una classe de 50 persones amb els horaris habituals i amb les classes habituals sense haver de fer classes especials. Jo crec que això és una molt bona decisió. El segon punt, i que espero que avui també succeeixi, comentava l'Oriol el seminari inicial que va fer el professor Tomás Lozano Pérez i que li va portar aquest moment d'asombro. Jo el que espero d'avui és que també entre la gent jove i la no tan jove també passi això amb el que s'expliqui avui a l'Oriol, que hi ha aquest moment wow, aquest moment d'asombro. I el tercer element que volia destacar és que, segons vas entendre, el que intenta desenvolupar Oriol és que no ens haguem de preocupar tant de desenvolupar solucions com de fer preguntes encertades. I tenir aquella pregunta que és la que realment t'obre el camí. Ja hi haurà les màquines que te buscaran solucions i que tindràs prou crítica com per saber si aquella solució és vàlida o no és vàlida. Però intentem fer-nos preguntes i, per tant, el tercer missatge que volia llançar és aquest, que d'aquesta classe, d'aquesta masterclass, surtin moltes preguntes, molts dubtes que portin a noves reflexions. Doncs jo crec que hem de rebre amb un gran aplaudiment al professor Vinyals. Professor Vinyals, de Flores Jurs.
Moltes gràcies. Em sentiu? Sí? Quan has dit professor pensava que s'estava equivocant. No sabia que era un professor de l'UPC. Molt bé. Bon dia a tothom. Buenos días, good morning. Faré la classe en anglès, però quan feu preguntes es pot fer en català, castellà o anglès. Ho deixem aquí, per això, només idiomes, per favor. So I'll switch to English. It's a great pleasure to be here today, dressed a little bit differently than yesterday, if you saw. It was a nice experience, very honored by the honoris causa. And it's a pleasure to be back. It's not the first time nor the last that I'll hopefully tell you some story about what we're doing, where we're coming from, where we're going in the field of AI and AGI pursuit. And this is a talk that I've given, but the field is moving really fast. So even if it's the same talk, it's really not the same talk. Like last week, we released Gemini 3, Nano Banana Pro. So you must update almost constantly slides and presentations with benchmarks and things that are on the frontier or are now commonplace all the time in this field. So hopefully some of you who are closer appreciate that. Some of you who are a bit further apart know that it is daunting even for us, the speed of progress. So I appreciate probably the amount of vertigo, I guess, that you might have about the field, but it is what it is. There's a lot of investment, a lot of interest, And it's happening. It's happening. We are building an alien intelligence, feels alien sometimes given the amount of mistakes or the kinds of errors that it makes or the kinds of things that it does for us. But it is an extraordinary time to be alive. Demis said very early days when DeepMind was only a small startup that this was the equivalent of the Apollo mission for landing on the moon, basically the pursuit to understand us, our brain, our intelligence, sentience, etc. So it is very exciting. Anything you do, probably this will affect you, this technology. You'll need to adapt, you'll need to hopefully advance it, investigate it. So yeah, it's great. It's a great pleasure to be here, to be able to talk about what we know today. As a tradition, I'll do a selfie first. So you'll get to see later, probably I'll tweet this, I guess, what my point of view is from here, which is amazing. So I think everyone more or less is in. Great. I couldn't do that yesterday. I felt it was probably not, not adequate, but today I'm doing it. Okay. So let's start this class is, it's not really a class, but I'm going to try to touch something, hopefully, from all of you as I model who is here, which I have no clue, obviously, but hopefully someone gets something from any section of this talk. There is obviously AI, artificial intelligence, and then there's AGI, which is artificial general intelligence. There's a distinction that hopefully will be clear to most of you after this. If not, at the end, there's a very long section of Q&A, which I'll probably eat into a little bit, given that I generally don't prepare for time, and there's a few slides to go through, but we can skip a few as well. But the first and very important object is, what is that we're trying to build? How do we define it? And this is a definition that is sort of the OG, the original definition from, I believe, Shane Leck, who is the co-founder of Google DeepMind, together with Demis and Mustafa. And it says an AGI is a machine that can do the kinds of cognitive tasks that people can typically do. It's quite a not very precise definition, because if you think people can typically do, like you'll say, well, people cannot typically win a gold medal at IMO, for example. But then you could say, well, but we want the best human, and we need to perform at that level, right? So there's already lots of nuance on the level of intelligence that we're trying to achieve. Is it the median human? Is it from which country? From the whole? It's quite unspecified or underspecified definition. Cognitive task is the other very important element here. There's a definition below. Cognitive tasks are the undertakings that require a person to mentally process blah, 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 blah. I think basically, think of anything a human can do with a digital computer. There's a lot of, obviously, progress in robotics and so on, but mostly, currently, we have lots of progress on the digital domain. So think of anything that a human could do on a computer, a skilled human. That's probably the kinds of tasks, this very broad task that we want to do. And I really like the part of acquire and organize knowledge to learn. I think that's a skill that, especially in a university, students, that I would say is the most important meta skill that came with me, I guess, from after undergraduate studies here and my doctorate in Berkeley. It's not so much about, I was kind of joking with some of my colleagues, I guess, now, yesterday, about, I don't remember much about rotationals or divergences or so on. There are things I remember because I use them in my work, but what's important is the ability to learn, communicate, networking, right? These places, universities, they might be transformed as well by the technology, but the human connection and those skills are definitely gonna stick forever. Never say forever, but I guess they're gonna stick for a while, and there's gonna be an interesting transformation to witness as well. So the funny thing is, even though there was the clear pursuit for AGI, especially when you see at early days of the only company that was probably serious about it since 2009, which was DeepMind, even the achievements you might have heard, and we'll review some of them, they were not really AGI, they were more narrow AI or AI. And so I'll first discuss a bit of the basics where we come from maybe to 2010 to 2020, where I call it the deep learning era. So what we were obsessed by at the time, it was a very academic era. We published a lot in conferences, gave many talks. And our obsession was certainly to train a neural network, generally, or a model, but neural nets, for those in deep learning, is the bread and butter, that would essentially excel at each of the tasks that machine learning community have come up with over the years, right? So there's a task of machine translation. Hello, how are you? I should probably change that to Catalan, but anyways, pixels, right? Like from an image to the class of the image. That's the ImageNet, classification challenge that was built for advancing machine learning, speech recognition, et cetera, right? So we had these single tasks, and our goal was to maximize a metric that was defined by the community. And interestingly, even at the time, we also start, especially in 2014, 15, and so on, starting to reverse to the modality that's on the right, that's mostly discrete text or labels. It's very low information density. To reverse that from that low information density to the more rich signals, which is especially audio, images, video, which tend to be very underspecified, right? If I showed you, if I ask all of you, hopefully you know, okay, that's a leopard, so there would be no uncertainty going from left to right. But if I ask you to draw or imagine a leopard, an image of a leopard, probably all the images would be all different because the entropy of pixels and the natural world is much more rich than that sort of process of distilling the natural world into language, which is a very human intelligence-like thing, and of course language will come back a bit later. So this was also an interesting problem. We did a bunch of progress, of course, here. And then we had, as I said, a few landmark projects, generally anything that starts with alpha from DeepMind. Pay attention. I mean, this is a project that has been devised to be drastic, to just multi-year, very ambitious, etc. So AlphaGo is a system that basically has a lot of interesting ideas that even to today, for the current chatbots that we have, apply, which had the idea of training a policy network that is just a neural network that, given the state of the board of a game, so the input is kind of an image, is 19 by 19, that's the full game of Go. So it's a fairly low resolution image if you think about it as an image. And we had the idea to first train to imitate human moves, right? So you have a large data set of how people play Go, like everyone, I mean, chess probably is more common, but you get all the games ever played recorded and you can just replay them. And through that data knowledge that exists out there, we distill that knowledge into a policy that was able to basically try to predict the probability of playing a move from a certain position in any place in the board. And that was part number one. The other part, very exciting, was from any position on the board, can we predict who will win this game? It's a fairly challenging problem. In chess, you can say, well, I mean, okay, one side doesn't have the queen, right? So that's probably pretty bad. Even in chess is a tricky thing to do to evaluate the value or how ahead one of the two players are. But that's another important element, because once you have these two elements, you can do tree search, but guided by probabilities and estimates of winning probability that are given by extremely powerful models, neural networks trained exquisitely to the level of then becoming superhuman. And then another very important aspect was the aspect of self-play. So once you train your prior knowledge from human data, what you can start thinking about is, can we get the system that can play Go at certain level to play against itself, and then reward the side that wins and penalize the side that loses, and then try to learn from that cycle that basically can go forever. And that was another very important insight used in the AlphaGo breakthrough that you would then see eventually on. It was streamed fairly massively, over 100 million views in the game against Lee Sedol, and AlphaGo did fairly well there. I'll go a bit quickly through these, but this is a project, it's close to heart. I like the game StarCraft. It came back over and over throughout my life, even recently, because somehow I promised Elon Musk I would play his system on StarCraft 3 days ago, and he accepted. So I'm on the hook to maybe learn to play again a little bit. I'm a bit rusty. But this project developed a lot of the techniques that actually apply today almost verbatim into the creation of Gemini models and all the other chatbots out there, which is the idea of doing pre-training, human imitation, but that is on a sequence of moves, which starts to sound more like sequence of words, language, etc. And then it does use that initial policy to then fine-tune with an RL, reinforcement learning loop. It's not that dissimilar from AlphaGo, but the imitation aspect here was critical because the space of moves unlike in Go, which is large, is 19 by 19 if you're very naive, the space of moves here is much larger, much like every sentence, every English sentence, if you think of that space, is a very combinatorial, large space, infinite space, and it's similar here. So we had to do a few tricks that end up being also quite useful in language modeling. Then, of course, AlphaFold, I discussed this briefly yesterday. This was another application, again, of a single system that could do something very important. Now, this system did something so important that obviously was recognized last year with the Nobel Prize. And the idea, though, is not that dissimilar from the classic machine learning paradigm. You have a bunch of data. You want to learn a mapping between inputs and outputs. The mapping needs to be powerful, nonlinear, and learnable, differentiable. Neural nets always come handy when that is the requirement. And then there was some unique challenges because the amount of data here was not as large as we had in Go or in StarCraft. There's only a handful, few thousands, tens of thousands of proteins that have been folded to the precision that we want to achieve or imitate. Just because, as I mentioned, it takes a whole PhD to fold a single protein, so it's a fairly intricate problem. And also, so we had to invent a few techniques to distill from unlabeled data, etc. But eventually, by finessing every single aspect of this system, we climbed from 30 accuracy over 100 to over 90, which then the community considered that within the error of doing this in the lab by crystallization or any other process that allows you to fold proteins more slowly. And of course, then we published eventually all the 200 million known proteins. We just processed them through the system, and we gave that as a data set for the world to use. And the model is accessible for any researcher, and it's been used worldwide, and it's actually just 5 years ago, I believe yesterday, so it's a nice moment to show this. And maybe why this matters, this goes into biology, but that's a bit of the fun of being in machine learning, and then machine learning kind of interdisciplinarily, that's a hard word to say, goes into all the other disciplines, right? So why this matters for real, not only as a, hey, this is a grand challenge and we solved it, is twofold, no pun intended. One is to determine these letters on the left, the input is cheap, is easy. You can sequence proteins fairly easily. When COVID came, sadly, then we got this almost immediately, right? It's a fairly cheap process to do that. To otherwise crystallize, as I said, is very, very challenging. So that is very expensive in time. This is cheap. So, of course, what AlphaFold does on the one hand is do the cheap thing, apply the model, the transformation, and then you get the thing that was going to take you years in basically seconds or minutes. The other question is, why does that thing matter at all, right? Who cares? Who cares how, yeah, coronavirus, okay, it might look like this or that. Well, it matters for many applications of biology. The one, and I am not an expert, so apologies if you know more than me, which is very likely, but to explain it plainly, you have this, let's say, a virus that has certain proteins and it has some shapes. a medicine, the goal of, and this virus attaches to your body through, basically, it's kind of a puzzle, and it's an evolution, of course, right? So there are certain proteins that attach to parts of your proteins that you own in your body, and that's one aspect, let's say, of getting infected. Medicine, one way to solve this problem is, can we attach a piece to the virus so that it makes it so that it doesn't attach so easily to you, right? So that's one way to then make the virality go down, and I mean, many other things that I have no clue about, but this one I sort of understand. So intuitively, it's a big deal to know the shapes of the things, so we can do a bit of a puzzling, kind of attach to this, don't attach to that, and so on. Of course, proteins might have side effects, so it's not as simple as I said, but this is a simplification of why this is a big deal. So to recap this sort of deep learning era, these are like 3 demonstrations of something that I call it as many AI demonstrations. They focus on models. The weights, the system is a model that you can then open source. But it excels only on one task, right? The Go system cannot even play chess, which is deemed less complex, mathematically speaking. The thing that solves proteins would not be able to solve a 3-year-old puzzle, et cetera, right? So these systems are narrow, and I also mentioned these in my talk yesterday. But what then, you know, when people at the time, right, you talk to the press and so on, you try to explain why this matters, and then the methodologies are general, right? So what at the time we were doing is, look, the applications are important, the demonstrations are impactful and amazing, but how we're doing it, the how was what was general, right? So what we were developing in parallel for all these, there's a lot of commonality. There's neural networks, transformers, stochastic gradient descent, et cetera, et cetera. These are general. But the models are not general, right? So we were not really in the models claiming that the models are AGI, but technologically we were discovering pieces of the puzzle, so to speak, to build eventually, hopefully, a model that we would claim is general and powerful. Now, I'd like to zoom in a little bit onto some of these key building blocks in some detail, just because they are close to heart in many ways. The basic one is embarrassingly simple. I mean, that's probably the math subject I remember the most as a result of applying basically nonlinear optimization day and night. That's how we learn the weights, right? So neural network is a differentiable function. You can use the chain rule, backpropagation, which obviously was not invented. This is a mathematical property of chaining different functions that is known for many decades. But there was an algorithm and an actual implementation making this memory efficient. And once you set up these networks and the weights are randomly initialized, you then run an optimization process to learn these weights, to make the weights fit the data as best as possible. It's classic optimization. And these objects here happen to be quite powerful, quite general, and have the right inductive biases, which is a notion that is important to understand, because even if they are universal functions, they might take more time to learn or to extract patterns from the data more quickly. And then you run an optimization process by gradient descent, many different variants and tricks, many of which are empirical, I would say, like you just look at the math and probably doesn't make sense. These things are non-convex, so it's a bit hard to study, and that's why they were fully dismissed in the 90s as not an interesting mathematical or object to study from an optimization point of view. So lots of resistance, but this is the key element. The brain looks like this. Each of these arrows is a weight, and to give you an idea, the current models you might be experiencing once you go to whatever chatbot and you type have about, let's say, 1 trillion weights, and a trillion here means a million. So imagine if you want to visualize the thing we train, the object we train is a trillion-dimensional real vector, real numbers, and it looks clearly much more complex than this toy version here. Now, another important work is that how do we model sequences, their variable length? They were very annoying for various reasons for neural nets. So we came up with a very simple idea back in 2014 with Ilya and Kwok, and that was the basis of internally at Google and certainly also externally to start to apply language modeling to more and more domains that require producing sequences of words or bytes. An image can be seen, of course, as a sequence as well. And there were certainly many more works applying neural nets to language. This is the one, obviously a bit biased, but the one that impacted probably internally as the most. So that was an important piece of work that exploded then internally and externally. Another important paper that sadly was rejected, this is my best rejected paper, I guess, in some way, but it's okay. Jeff Hinton did a good job at going and giving talks about this, despite the fact that obviously we didn't have an official spot at NeurIPS 2014 where it was rejected from. But distillation is an important technology that even today it helps, because the main notion is that you can train an expensive model, a large model, that might be not cheap to serve, right? So we serve, I mean, I don't know, quadrillions of tokens per some unit of time at Google. So every one of these computations needs these 1 trillion weights loaded and doing compute-intensive tasks, which requires energy, money, etc. So what we tend to do is we train a model that is the most powerful we have internally, but is not deployable at scale, and then that model can then use to teach the small model to be almost as good as the teacher. And the method that you use to do that is intuitively the following. When you train on a data set of text on the internet, you encounter sentences, right, that people write. So one sentence could be, perform the concerto for violin. That's a sentence that might exist and it's written. And the model is going to try to predict the next word that happens to be in the corpus for that particular sentence, right? So what you're going to do for training this is going to say, okay, given that I've seen perform the concerto for, the model is trying to predict which word comes next, and of course, you don't know for sure which word is going to be next there. The corpus is telling you, violin is the one I want you to produce for this particular training instance. So you're basically going all in, right? The model might say, look, I don't know, there's these possible words. Then you do gradient descent and say, no, the word was violin, so you get penalized for all the different words that were not violin, because that's not the correct word, given this particular example. And what distillation does instead is, wait a second, I know already a little bit about the world. The model that I trained, the larger model, has expertise on the kinds of sentences and words that go after which words. So do not predict just violin. I mean, maybe boost that a little bit, because it's actually in your data. But hey, the words might be, there's a distribution, make bets about which is the next word. So it could be violin, piano, trumpet, probably not airplane. And then use that as an extra signal, so the gradient step that you're going to take has more information. And that kind of felt cool at the time, but now it matters, because believe it or not, we ran out of data. Like, we train on all of the internet, again, trillions of whatever you need, words, tokens, etc., that we use, everyone uses to train. So the game now becomes extracting more from the data that we have is the bottleneck for the next generation of models. So these techniques become also very exciting as a way to reinterpret in some ways the data that we have by the powerful models that we already have at our disposal. So very important rejected paper. Other things that happen, again, I'm being a bit more Google biased, but I guess it makes sense, especially given the stuff I'm wearing today. We invested, there's GPUs from NVIDIA and TPUs that Google created many, many years ago, quite a lot of foresight to predict this would be a big deal to do. So we have large data centers with lots of interconnected hardware, very interesting problem. Again, I'm not a hardware expert, but there's a lot of interesting things that happen. You have a chip that's very powerful. You need to bring in these weights that are massive into the computational units. That takes a lot of energy. And then these models are very large, so they don't fit in memory. So you have to start architecting ways to communicate different bandwidth layers. The chip has lots of memory bandwidth because things are very close. Then groups of chips might be kind of closely location-wise, and then you can imagine a Google data center as large as, I mean, I don't know, actually, I've never been, I should try to go, but let's say as large as a bunch of buildings here, and then, of course, the bandwidth and the latency there starts to affect your performance at training time. So a lot of care, a lot of investment goes into infrastructure, energy consumption, cooling. It's a very interesting area, and as a researcher, you need to try to tell people that will build these in 2 to 3 years what's going to happen with the architectures, which is not an easy job, and it feels also high pressure given the cost involved, but it's part of what we do day and night to obviously have the engineers and the researchers communicate with data centers, planning, etc. Now, the last piece before I go to the next era is the exact formulation of the neural network. So the transformer paper, extremely influential paper. We tweaked this architecture, but surprisingly, there's not much variation that the current models use on top of the original sort of formulation or architecture. And these happen to have the power of neural networks in terms of being universal mappers from any input to any output. But they are very good at learning very fast, very efficiently, so they learn very quickly. That generally was a problem at the time because they overfit to your training data, but they really like lots of training data, which obviously that happened when we start training at internet scale. And then there's there's another very natural inductive bias, which is the concept that as you read text and you try to write the next word or the next sentences, you pay attention selectively to what is written before, right? So the previous model, recurrent neural networks, tended to compress all the context into a single vector, whereas this was a very good inductive bias to extract information actively from your context. And that helped a lot, especially in language modeling. And also, it happened to be a very good property from an optimization point of view, because once you do backpropagation over time, you get basically many matrices multiplied together, and there's issues with eigenvalues that dominate, etc. Whereas here, the gradients with respect to every word that you've seen from a whole book happens to go through a constant number of backpropagation steps. So there's lots of properties here. So we have powerful models. That's exciting. The next thing that probably is the most important thing that happened in the last, let's say, 10 years, and I mentioned it brings the generality, the G, back into AGI, was language modeling. Maybe in hindsight is obvious, but language modeling was this kind of field that even Shannon already was dreaming about, right? There's this idea that you can probabilistically try to compress text and determine how many bits are in English, for example. And compressing was the obsession. We all know what compression means. You take a file, you compress it, great. You send it through the internet. When internet was ultra slow, that was awesome. But compression was sort of the wrong angle. What happened over the years is that these compressors understood language, so they could compress information to the bits that would be necessary to explain the next word. So in the violin case, maybe given that sentence, there's only 5 words that come next, and a word would necessitate maybe 8 bits, right? So the compression factor is massive if you understand the text, and that was generated by a human. But you can also flip this around and start sampling from this probabilistic distribution. You have P of basically x1 through xn, and you can just use, again, a form of chain rule to sample from left to right words, and the words that come out tell you a little bit the model that these language models have created of the world. primitive language models, they kind of make sense locally, right? Like, I mean, $6 billion, okay, that's a set of 3 words that you might encounter somewhere. But then as we went from n-grams to neural networks to eventually transformers, this was a massive, massive improvement over the quality of the text that was produced. So at some point, there's like, wait a second, this is just not a compressor, this is a generator. And what is the usefulness of having a language generator? I mean, you know the answer now, but at the time, we were playing with different things. We generated translations. I mean, that's certainly useful, right? So we use it for a bunch of applications. And probably the main, I mean, I mentioned the transformer, so maybe I'll skip this, because timing probably is tight. But let me get to the GPT series of papers. So we have these generators that starts to produce interesting text, and then GPT-2 was really, in terms of the how, like how do we train these models? It established the whole way that this happens. Further are just refinements and honestly just scaling up in some instances, but GPT-2 had a modestly sized data set of 40 billion words, that's 40,000 million words, and parameters, we're still in the billions, not trillions, so 10 to the 9, not 10 to the 12. And used transformers, but I think even probably more than transformers is the fact that it was trained on all of the internet to model all the text ever produced by humanity as approximately correct as possible. And that created this magic generalization almost that you could feel already in the GPT-2 paper, where they trained this model just to model language over all the internet, and they start to see that it started to perform well at this narrow task that I mentioned in the first section of the talk. It was fairly accurate and even state-of-the-art in one of these traditional benchmarks like machine translation or natural language parsing to like parse trees, etc. So that was a profound realization that you could train a model to model the internet. That model could do everything, kind of. And then, of course, this notion was and has been improved over the years through mostly, I mean, I just put these 2 numbers because the parameters and the number of words that it's trained on are and have been quite telling in terms of the capability to expect, and I'm getting to that in a second. But of course, there's also refinement on the recipe on how these models are trained that is quite important as well. So the leaps, some of us, of course, in the field, GPT-2 already exciting. GPT-3, I think, felt more mainstream, research mainstream. And certainly between GPT-3 and GPT-4, that's when ChatGPT happens, an application that surfaces these models in the right form factor that makes it exciting for pretty much everyone in the world to experience with. Theme park episodes are being built on top of the ChatGPT, so super important moment in 2022. Now, scaling has happened, right? Empirically, we can plot, hey, by when we publish models, how many flops or what's the compute intensity we use to train those weights. And we see sort of 3 different areas, pre-deep learning, then deep learning, which we studied, that's growing considerably to 1 E20 flops to train a whole model from scratch. And then in the large-scale era, in large language models, we've seen another shift in the curve above. And this is a bit outdated, and this data is proprietary. Like, no one says exactly how many flops we use to train, but you can imagine from this graph, make your own prediction, and it's probably going to be fairly accurate. So why scaling up happened to be good? So we had this paper where we empirically discovered that there were emergence in properties of these models trained on all of the internet as a function of scale or amount of flops you train it with. So let's take just the top left here for simplicity. If you train a model, again, on the same data, it's the same model, you just make it larger so that it's basically trained on more flops. And you ask to do arithmetic. I mean, this is literally, you ask a language model, what's 4 plus 4? I mean, these were fairly early days. The model might have no clue even what you're asking about, or certainly not give you the correct answer, but you can measure that. So you measure that performance, and at some point, the model, for no reason, you're just scaling it up. You're adding parameters to those little, you just keep adding all those little balls. Eventually, it goes from not having a clue on basically adding numbers to actually performing decently, right? And it's a very sharp sort of increase. And that's sort of an interesting property, because as researchers, you say, well, if I kept scaling, could this model win a gold medal in maths? And I mean, the answer is yes. But at this time, we were studying it more empirically, and we observed these issues. So obviously, as the whole field was curious about, if we kept scaling that number, 24, 25, 26, what would be the thing that the models can do that couldn't do before, right? So very important notion, and why you see all the investment in compute to test these hypotheses. There's many other reasons to invest in compute, but this was certainly in the early days a scaling hypothesis that for us was very critical to explore as fast as possible. So now we have general text models. Enter Gemini. I mentioned the ChatGPT moment. That ChatGPT moment was very interesting worldwide, certainly. AI was not, AI was obviously in the public interest, certainly, since many years ago. But that moment definitely made a massive shift. And one of the shifts was that we had a bunch of groups, 2 groups mostly in Google, running large language model projects. And after that moment, it was clear we had to get all the talent together into a single project, and also all the compute together to get to those numbers further to the right, faster. So different moments where the project started, but in February 2023, Jeff and I started sort of building this project to create the best models in the world. Google was still catching up. We had obviously invented a lot of the key technologies, but in terms of the weights produced by us independently as 2 entities, we were certainly not at the level of the best models. So the goal was clearly get together and, over the years, perfect the recipe and get to the top as fast as possible, because this is no longer an academic exercise. This model surfaced to the world, as all of you have experienced, can do all sorts of amazing things, and we'll see some of those a bit later. So the project starts. We have a series of models. The 3 literally produced last week, so very recently. And I'll describe a little bit of certain properties of Gemini, the model that powers pretty much every large surface in Google, YouTube, Google Search, Gmail, Google Docs, Maps, et cetera, et cetera. It really went everywhere. So it's kind of the brain that is now powering lots of the billion user plus products that Google has created over the years. So it's a fascinating transformation to have witnessed. So 3 Pro was released just last week. Obviously, you release this and you get a reaction from someone who releases something else. So you never claim state of the art very strongly in the field. You definitely learn that, we've learned that fairly strongly. But this model felt, 2.5 Pro was really good, and in certain aspects, definitely probably at the frontier, meaning the best. This model holistically also extremely powerful, improved on many aspects. It's much better at understanding text in images, both input and output, for example. And then we have a lot of metrics, right? That's another interesting aspect. Like, how do we measure AGI? It's general. So we have a bunch of benchmarks that go from, is this thing close to a gold medal mathematician, to can it code beautiful apps just by a prompt, to GPQA, which is a kind of a more like exam-style general knowledge way of testing. There's a lot of academic and science tests here, because we've tested, obviously, ourselves. We pitted ourselves against, obviously, exams all the time. So there's a bit of bias, academic bias here. But of course, ultimately, you have these, and you just want the users to, do and explore what these models can do, which is very fun part of my job as well. But there's lots of benchmarks that we measure to assess progress between, current generation and past generation, like 3 to 2.5, and of course, whatever is felt as the state of the art, which is Claude, the Anthropic model, or GPT 5.1, the OpenAI models. So this is obviously a very important aspect to develop models, to assess how far we've gone from the previous ones. And then there's many other aspects. One is, as I mentioned, users. So there's this website called LM Arena where users go, prompt 2 models that the user doesn't know about, gets 2 answers, and picks the one that it likes the best. And again, for this particular release, we broke 1500 ELO, which is kind of one of the interesting but artificial boundaries that we were hoping to do with 3.0. So barely we broke it. And then it's very good according to users and held out sort of data compared to competition. But the margins also are not massive, right? Like you have to understand ELO scores. A difference of 400 ELO means the probability of winning is 90%, I believe. It's developed for chess. So if you look at differences of 50 points, 30 points, it's barely like, in a side-by-side, it wins like 2-3% of the time above the other one. So it's not a massive difference. All these models are awesome in different ways, have different personas or personalities, lots of interesting things for you to experiment with as a user. And then the last bit is text is important, but different modalities are very powerful. We are very visual. We talk to each other. We move in the real world, so there's still a lot to unlock. So we've had some early work on how can we bring pixels into modeling text. And we had a couple of attempts, but the one that is closest to how we do it is actually this one, where it's kind of the simplest way. You take an image, and you just compress it into a sequence of symbols that try to compress the image. So JPG does something similar, although we don't use JPG, that would be not too good. But we just use this notion of compression again for an image to be represented as a sequence of numbers that can be decompressed to be the image, but that represent all the details, even the letters, etc., present in the image. We perfected, of course, how we encode an image to be then represented as a sequence of integers. And once we have the sequence of integers, we just inline it in the model, and we train. Sometimes a data point will contain images, text, images again, and that is how you get this generalization of being able to interleave modalities in any way that the users creatively do indeed. So this is sort of how we added multimodality, and then since day one, we wanted to be native into not only text, but audio, images, and video. And it's been a massive area of investment since 2023. And then on the output side, our focus was mostly on text, but we've also tweaked the way we generate images quite massively. So this is the thing I'm wearing, actually. This is meant to be banana color somehow. Not sure which bananas, but we developed and perfected how could we also produce these images at the output, not just at the input. And last week, we released Nano Banana Pro, again, topping the leaderboards from user preferences or capability to edit the image and so on. But this model, unlike most of image models, you would just write some caption, draw me a leopard, and you could add more detail, and you would get the image out. The usability improvement we had for the moment that we released Nano Banana earlier this year, and Pro is much better at rendering text especially, is that you could just also edit images, right? So I know probably some of you have used this. You can upload a couple of pictures and say, put this little boy into this UPC campus, which is the image I showed yesterday, just produced by Nano Banana. So you can edit images with language very intuitively, rather than needing specialized tools that are only available to specialists that have perfected skills on those tools. So that's becomes a skill that is much more available to anyone that can be creative now with expressing combinations of images, editing, and so on and so forth. Of course, it changes how the professionals do it, and we think about this all the time. We always show these tools to filmmakers, etc., right, for them to understand what's coming and guide us a little bit in the process. But this model, and I mean, how I did this slide is as simple as I took the results, a screenshot, and I said, I mean, put some bananas and make a nice title. So the letters actually are rendered from the model. These are not fonts you could edit. If I want to edit, I would need to go and ask the model, can you change, maybe can you change the slide to Catalan? We could try it maybe offline if it should work. And then last modality is video. So we release video, and this is kind of the beginning. This video is a bit fast, but it generates pretty awesome, realistic and unrealistic creative videos. And again, we release this to the world, and it's quite amazing, but I would say, these 8-second clips, there's a lot of room for improvement in here, but you can see how you eventually might want to communicate with these models. And sometimes the right answer might be produce a short video to explain something or to teach you something, etc. So very exciting. And with all these advances, we had not just general text models, but general multimodal models. Now, this capability is perhaps a bit more deep into what I think is more at the core of the definition of AGI. And the best way to describe it is, these models are great. You can instruct them. They will follow your instructions most of the time. If you instruct them to do something not nice, they're meant to also push back and so on, right? So there's a lot of configurability in how you then program this, which is through language. But deeply, they don't learn new things in the way we learn new things throughout years of attending university, right? So imagine there's a new field or a new degree that the UPC creates, and we record the first cohort. We record all the classes. We have all the materials, the homeworks. An awesome capability would be to show all this information to the model that is already been trained. We're not going to add this to the training set because it's data that's in the future, so how could we? But this data that now appears in the knowledge of human knowledge that's been created by new discoveries, etc., it would be awesome to add that into the context or somehow instruct the model, hey, read all these videos for hours, and at the end, I expect you to be an expert of this new field that someone here maybe has discovered, a new field of mathematics, for example. And that capability is not quite there yet, but it touches the learning aspect of the AGI definition, the cognitive tasks that you can learn. And I think this is sometimes is called in-context learning, and a critical aspect of this is the ability to process vast amounts of information after you've trained the model, right? Obviously, we train on a lot of information. That training data goes into the weights as knowledge, but once the model already exists in your chatbot, you can upload documents, pictures, but it would be awesome to upload something deeply, a new game you've invented. You want the model to be extremely good at it, and that is something that is still not even explored that heavily, but the ability to process very long contexts of information, eventually infinite, is a capability we've been exploring a lot, and in 1.5 we had a massive breakthrough that obviously keeps being in the model. I'll skip some of the technical details and how to evaluate, again, in the interest of time, but I'll stop here because this long context also has enabled the ability for the models to reason internally before producing an answer. So this is a slide I took that was explaining how O1, although now all the models have this reasoning capability, and you can ask a question, like what is the last digit of 7 to the 9999, and then the model could try to guess, right? Just output a number. I mean, it has this powerful nonlinear function, so it could possibly, in the weight, somehow do the computation. But by breaking it down and writing kind of for itself how to maybe answer this complex question, It improves especially mathematical abilities, science in general, and programming massively. It has a cost because now you have to wait for the model to output all this before it outputs the answer. But this technology is a breakthrough that's here to stay. All the models will reason. They shouldn't reason for 3 hours just to reply hello back, which is a problem sometimes we see. You say hello, and the model starts to think, what does this mean? I mean, hello, should I say? So it's an interesting phenomenon when you add these capabilities to the models. But clearly, the basis is very logical. You give it a scratch pad. And then to do more complex things, this scratch pad becomes fairly long, hundreds of thousands and beyond. And so that's why also long context capabilities, to have it in the working memory of the model, is quite important as well. Now with this, last week as well, we updated our best models, and we have these 3 different benchmarks. Doesn't matter too much. Funny name, the first one, but there was a belief that that would be the last exam that humans excel over the models. It was released maybe a year ago. Models were at 1%, and we see already 40%. So the progress has been extremely fast. And maybe more fun, especially for those of you who are into maths, we had this IMO Gold competition. This, I believe, is problem 3. So humans are asked to solve this problem. I know many of you, especially I was chatting about this with Dr. Granet yesterday. I was trying to explain how the model works. I'm not sure I succeeded, but I told him, look, go and read the solutions, which are this link at the bottom, if you're interested. But it's quite a daunting thing to see this, right? I mean, I am a mathematician. I read that question. Today, I'm rusty, so I might not even understand it too well, but OK, I get it. And then, I mean, at the time I finished reading the question, I mean, the model already has written all these sort of cases, lemmas, and so on to aid to basically conclude, after lots of writing, that this number is 4. And then what we do with this is we send it to the judges of IMO, and then they basically granted Gemini the gold medal just in the summer. So very interesting experience to see how the field that you think you're an expert goes so quickly in front of your eyes, and you have to then spend the time to learn what it did. Of course, it does mistakes. Sometimes it might hallucinate things, which is great if you want to try to, you don't know the exam, you invent the theorem that helps you prove what you want to prove. But critical mind is important, right? So we need human experts. We have a few gold medalists in our team to, of course, assess the model performance, because this is at the level that not many people can then read this and understand if it's elegant, if it's efficient, and so on. So go read this, and you tell me how you found these solutions. This is the 2.5 model, so obviously the current one is meant to be even better than this. So I'll finish, I guess, perhaps just to show a little bit how does this all come together, because these numbers, you don't see kind of the real impact to the real world. And it's very important as developers of these models that we see how the world reacts, what do they do, what are the issues that they find, because this iteration between us, the creators, and the users is very important. It would not work, and probably it would actually detriment progress if we went on a secret lab for many years, developed these models, and then eventually say, OK, here is AGI, or here is some very powerful thing. So this is a very nice property, and we love to see what people do with this. Now, I have too many of these, so maybe I'll show a few of my favorites. There's so many that I like. The first one is actually how the interaction with applications might change because of what these models can do. So this is basically is built into Google, and depending on what you ask, right? You can upload a paper and then ask about some notion in this paper you want to learn. And what this is, you can try this yourself. What you will get as an answer is not just a query, a piece of text or a link. What you get is a UI that is tailored to your question. So it might generate a little applet that to show what, intuitively what this might be and so on. So you can imagine that the way we do question answering, which is obviously the bread and butter of Google search, changes, and it produces not only better answers, but also experiences that make it much more easy to then grasp and learn that concept. We have obviously a lot of bias towards science and very advanced queries, but you can imagine how this changes the experience. And we're experimenting with these, and we'll see where this goes, but it's a very cool property that the way the answer is presented now is dynamic, and the model decides what's the best way to do that. I think there's a lot of vibe coding. I don't know if you know this, what this means, but I think I'll skip this one, and I'll skip this one probably as well. I mean, cooking is fun. Okay, anyways, so I just have here a bit more. Coding is a very important application. So users, I mean, we use obviously social media to interact with our users majorly, are just doing things, incredible things, right? So this person here created a Lego simulator by just asking the model to create one. So you can imagine how video games or applications might be kind of almost local, right? You don't have anymore an application that someone builds and for years exists. You will just get a user that wants to do something for a few days, and then it builds the Lego simulator, and maybe, I mean, they get bored, and this might be shared or not, right? But it changes a lot, computation, user interaction, etc. So that's a cool example of the capabilities for a user that might not have ever coded anything to just ask for a thing that requires a piece of code to run in your computer, and Gemini 3 does code it for you, and then you can just interact with it. Then some other things you can do. I mean, this person asked about simulator of a nuclear plant. So again, super useful for education or understanding things. I don't fully understand these. I would not recommend building these. I mean, it's difficult. It's a bit obviously toy, but I don't know. It shows kind of the creativity of users that have very different interests, right? As a kid, I could imagine me like trying to understand all sorts of things in science and then seeing it in my screen almost immediately if I ask the question, right? So it changes the world. Then also lots of different cool tests. I think people often have a query they have in mind that is not part of any evaluation, and they ask all the models to do it, and then they compare, right? So it's not very scientific, but it's a way to evaluate models. So here, a person who always asks to do this Pelican in SVG, and I mean, this was impressed by Gemini 3 in this case. Again, another simulator for Rubik's Cube. Anyways, the world is, creativity of everyone in the world that is passionate about this is not, you can't do this from any company, even as big as Google. So it's very awesome to see how users are interacting and feedback, and so please do that, keep it coming. We listen, we look at things. As you can see, this is even less than a week old, and we have a lot of things we gather for then our understanding. And anyways, as I said, there's so many of these, all very cool, like Ali, who's actually in my team, wanted again to understand DDoS, so this is a UI, but it created this little simulator of DDoS, which if those in telecos probably understand what this is, but anyways, lots of interesting applications. Again, I have too many of these, and I want to definitely save some time for questions. So take a look, play with yourself. Language is all you need. And then last but not least, there is obviously the aspect of generation, which we also updated last week. So as I said, you can do these sorts of things, right? Like ask to create images, but the text rendering is really good compared to other models. So you can do all sorts of creative work here with Nano Banana Pro. And as I said, we focus on the text and the detail because both the input, the understanding, and the generation has improved a lot. So here's an example of the attention paper, which I had a screenshot of, and then someone just asked to annotate this for their understanding. And you see this text rendered in the image itself that explains all the different components of the transformer architecture. Also kind of wild to see how design will change. So here you have as an input, my dad is an architect, so hopefully he likes that one. You have a blueprint, very technical, not many people can read this. I can, obviously, because I've been kind of forced throughout my life to understand these things. But you can put a blueprint and then ask it to render it. And it just does it. And you can imagine, not in the future, you will get a program that renders this. You can navigate in it in 3D, and all you need is the image. You don't need an expert helping you, which, of course, probably will do a better job, but it will also take a while to do. So very cool capabilities are being uncovered by our users. This one I like. This is also Mostafa, who is actually in my team. The model cannot only output images, but also reason in image spaces. So all of you have seen these puzzles. Oh, if you pass these, your IQ is over whatever, 130. So we haven't quite tested visual IQ yet on the model, although IQ, I think, there's someone who does it all the time. But the model here, the best way to solve this puzzle is actually by simulating it in image space. So the model sort of reasons. It's not perfect, right? I mean, this is somewhat cherry-picked, but you get it, right? Like, not always these reasoning traces will be in text, and certainly for geometry problems like this one, thinking in visual space, even video space, and of course textual space is an important property of intelligence, and we're starting to see these kind of properties emerging from the model. Again, other cool examples, annotating images to understand, like, you know, this airplane, maybe this understands it better than the creators themselves, but of course, it was a time of brave tests when flying started. As I understand, there was not a lot of science behind it, so great advancement, though. And then again, Jeff also asked for the planets, and, you know, people asked about Pluto. I mean, I also thought Pluto was a planet, and then the model said, sure, here is Pluto. So, you know, lots of cool things we're seeing. This is my last example. It's a bit wild. I think these are very interesting, because the first one is it's solving the math problem, but it's literally solving it in the image, right? It's not like understanding the problem and writing a bunch of text. It's actually writing it there. I didn't check correctness here, by the way, so someone could do that. And then the one on the right is also very wild. It creates this fractal effect. It's a fake picture, of course, but you ask it to understand, kind of taking a picture of a picture of a picture, someone drawing it, and it just does it. It's to be honest, it's unclear how the model does it sometimes, but it's amazing. And this is, I think, Sundar posted this, since obviously there's a lot of San Francisco bias in the company. So I have a few open challenges. Again, maybe I would love to maybe have more time for questions. So let me just say that maybe the main challenge, so evaluation is very challenging. Numbers go only this far, and only when you get real usage, you see what the model is actually good at and also what the model fails at, so very, very tricky. Data, we ran out of it, so there's a lot of challenges on how to extract more from the data. Distillation is one way, but there's lots of research here to be done with regularization and so on, that machine learning basics can come back to help LLMs, which hasn't been needed until now. Modeling, I think modeling is actually, transformers, I would bet not against transformers, although I'm sure there will be someone coming up with the next great architecture. Pre-training, you know, very massive scale infrastructure needed. So I think for countries to be able to pre-train models, you would need a lot of investment. So the challenge is the cost. Pre-training is very costly. It is absorbing all the internet knowledge into the weights. And then last but not least, I think this is the area where there's a lot of cool research to be done. It is very challenging to do reinforcement learning with a model because, unlike Go or chess, we can't get the win condition, right? You ask for a poem, and you will like it, you will not like it, and how do we evaluate objectively whether the model is doing a good job, and we reinforce that, like, hey, you won the game of Go, good job, do more of this, versus all the different all these tasks that are very subjective and very difficult to grade. Even IMO, I mean, we need human experts to tell us if, I mean, this is actually a reasonable reasoning trace and answer. So it's extremely challenging to evaluate. There is a reason for hope, because evaluation, I believe, fundamentally is easier than creating the answer, right? This is a bit of the MP argument in computer science. Once you see the solution, it's easy to verify it, very hard to create the solution. So I'm hopeful there's a lot of innovation here to be able to evaluate models, but this will, I think, be the main driver for progress in Gemini 3.5, 4.0, and beyond. And then many other issues, factuality hallucinations, cracking self-improvement, safety, especially as we give access to computers. These models, I mean, should you have access to the internet? Internet is not a place where you can guarantee read-only operations. So there's a lot of interesting aspects that we can discuss maybe offline. And then last, to conclude, Shane in 2009 had this plot predicting that by 2020 there's a 50% chance of AGI. And this is not too bad. And 2009 is a long time ago. So I give it to Shane for having predicted at least some form of declaration of AGI fairly accurately. We'll see what the scientific community agrees or disagrees with. We tend to disagree as scientists always do, which is of course fine. But very exciting to see where it goes. As I said, extremely exciting time to be alive. I'm happy to share with you many more things during the Q&A. But in the meantime, thanks for your attention, and it's been awesome to be back in Barcelona. Thank you very much.
Okay, so thanks a lot, Oriol, for the nice presentation. So as you were mentioning, tenim temps per recollir les vostres preguntes, qüestions. L'únic que heu de fer és raise the hand, algú vindrà amb un micròfon per tal de que podeu fer les preguntes.
Okay, now. Can you hear me? Yeah. Well, thanks a lot. This was very enlightening and insightful, and thanks for returning to the city and bring all that you know to us. I think the city and the country need more people like you, so thank you for that. My question goes a little bit towards the last point you mentioned on the reward function. I see a lot of work that you guys are doing on scientific breakthroughs, and that's amazing, right? On fields of medicine, of science. I wonder how much are you guys thinking on deeply more philosophical questions, like helping increase levels of happiness or solving for world problems. Is that part of your research or not? Or how do you guys think about that?
Yeah, great question. I mean, if assigning value or reward to a well-posed mathematical question is already challenging. I mean, a global matter like global happiness, wealth, well-being, I mean, I can't imagine it something maybe harder to evaluate and for us to agree with, obviously, as we know, there's lots of different opinions in the world, and I mean, that's part of being in very different societies and how we configured or happen to be configured with different countries. That being said, I mean, obviously, as these models advance, the understanding and the ability of the model to be able to, as objectively as possibly, understand situations, mediate, and so on, is certainly something we've been studying. But it's still fairly early days because it's more of a passive thing, right? We can't possibly train the models because we don't know how to reward them for these kind of situations. But the models have emerging capabilities, so we certainly can do experiments, and it's a great research field, actually, to understand all sorts of like how would these models have done in this situation or that situation, negotiations, etc. So it's certainly a very cool application area. And then the way that it would go if it's to follow some of these breakthroughs we've seen is, can we measure it? So at least we can evaluate it, so we can assess, is this model release, even if we didn't train it for this, improving? Is it good enough for maybe someone to do a pilot in the real world scenario? We're not even at that stage yet, but I think this would be a very exciting way to use the models, especially since they might be seen, especially once you give all the information, hopefully can more objectively assess things. But there's always subjectiveness. They're imitating human behavior. So it's a bit a tricky topic, but certainly a fascinating one. Thanks.
Okay. Okay. Hello, Uriel.
Okay.
Very nice to have you here. I have two main questions. The first is, what would you recommend for students who are getting to such a fast-changing landscape? What would be your first recommendations or future sectors to aim to? And also, with your trajectory, obviously, what things have you learned leading a global impact team that you wouldn't learn in a classroom?
Let's get to this. I didn't quite hear the last part, but okay, let me answer. What would I recommend? Everyone is very different, so it's very hard to give generic advice, but I guess I've been saying it, and let me explicitly state it. Use the models. There are new technology, like the internet. When I was probably at the age of trying to break away, internet was just happening. And I remember my parents were not very happy, and now they're all addicted to it. So So you will see things happen, and you'll be able to adapt much faster than others. So first, learn the technology and be a user. It's a tool, and it's here to stay. And then focus, and that's maybe to the second question. I didn't fully grasp it, but what matters the most is there's soft skills, meta skills that you get from interactions with others, how to influence in the right ways, how to understand problems, how to communicate, how to think deeply about the problem, the questions to be asked rather than details on how to code the answer and so on. I think there's a transformation on those things, and I would focus on these meta skills that the ability to learn, to continuously adapt, given it's a fast-paced world. Focus on this. I don't know if there's ways to do this structurally in society. Certainly, there's going to be, I expect, some changes applied from the top down, but certainly bottom up, you should seek for these. And for me personally, I remember when I was an undergrad here being reasonably obsessed with grades, because that was kind of the objective function, right? I don't know, that's what you get evaluated on. But then in hindsight, I don't know, the grades I got, I didn't explain to Google, oh yeah, look, this is what you get evaluated on. It's important though, because the grades were not the point, right? It's more other things that happen here. So try to understand the big picture, even though it might be difficult depending on which stage of your career you might be. But in hindsight, definitely, lots of things that are non-quantifiable, hard to assign numbers on, those tend to be the ones that stick, and certainly surrounding yourself with great mentors and network, which here is a great place to start from. Very, very crucial as well. Cool. More questions?
Hola. Moltes gràcies de part del Pol. Anava a fer-te una pregunta que és super similar a la que acaben de fer, però més des d'un punt de vista d'empresa, no tan personal, i no tant demanant consell, sinó més aviat preguntant si des de Google, degut al canvi que genera, que comentaves a l'inici, el canvi que genera aquesta tecnologia, la pèrdua de feines que hi haurà i tot el que comporta això, si es fa una planificació del que serà el futur, ja que s'han sentit a personatges molt coneguts parlar de salaris universals i de coses similars a aquesta. Moltes gràcies.
Okay, I'll answer in English, but it's just hard to switch my brain, I guess, maybe. I could try, but maybe not now. This question is good and complex. So it's a bit, there's a lot of uncertainty and the kinds of things that change. I mean, there's some like, okay, are we gonna need, are these models gonna be better at the high level strategy or at the implementation detail? And to be honest, it's not clear. I mean, high level actually might look better if I look at, we're trying things like co-scientist, which is someone who you just kind of brainstorm with ideas, but then the implementation, especially in machine learning, is very hard to implement. These models are good at coding, but not as good. So even understanding which parts of what we do inside of Google are going to be accelerated and they might need a different shift of like then personal and so on is super hard at this point. But of course, in a year, maybe it's going to be very clear. So we're thinking certainly about using these tools. It's kind of almost necessary that people that work in Gemini, for instance, use the model for all sorts of things. At the moment, though, we've grown in terms of people in the project. I mean, Google-wide is a different story, but since 2023, Gemini was maybe 80 people, now is over 3,000. So there's definitely, at the moment, growth in terms of we need more people like helping with the project itself. That's the one that's closest to me. But yeah, we do think about both self-improvement and using it to automate or help us scale up, and then how will that change the shape of the company, like very much, lots of conversations, but the level of uncertainty now is very high. So I expect we have maybe 1 or 2 years, but we'll experience it much sooner perhaps than society, given both the bias that the model tends to be. We are scientists, so that's where there's a lot of science applications, and we obviously have these models before they're released, right? So, but yeah, I think immediately it's not super clear, but there is a change coming, and we're just looking at data as much as we can.
Hey.
Yeah.
Hey, Uriel. Thanks for an inspiring talk again. My field is multilinguality, so you know what's coming, I guess. You mentioned, in fact, let me follow up with the question. Preguntaré en català per així aprofitar, que no ho podem fer mai. A veure, has dit, aquests models l'únic que necessiten és la llengua. Vale, la pregunta és quina llengua, no? I com d'important és extendre-ho a altres llengües perquè no hi hagi potser un gap de multilingualitat i com hi esteu treballant i potser també el número de llengües que aneu i tot això.
Yeah, great question. Obviously, I'm very multilingual, bilingual race, and of course now mostly using English as the main communication tool. It's a great question. I mean, let me break it down with different kinds of answers. One is that there is, if you want to do something and you want the best performance, you probably should use English to ask the question. So, for the IMO problems, we didn't actually try, but if you just use a different language, although maybe IMO is easy to translate, there's only a few words, but you could, if you want maximal performance just because of how internet and obviously the bias of being built in the US, most of the models you experience, you will see a performance gap. So that is a reality. It's painful. I get pings from Googlers, Catalans like myself all the time. Hey, Gemini, what's happening, and so on. So the next stage is, okay, there's a gap. What is the gap? How do we evaluate the gap? So we're doing that. At the beginning of the project, we had to catch up and so on. Now, Google is obviously global. So all the languages, especially the ones that are kind of P0, meaning spoken by large groups of people. Catalan, I think, is not in that tier exactly, but we actually measure Catalan as well as many other languages, measuring the gap and then closing it, right? If anything, we deep learners, machine learners are good at is if we can measure something, we're going to hill climb it and it's going to get better. And in fact, as a user myself, when I give talks trying to use it to translate, including yesterday, I mean, I just used Gemini. I wrote the thing in English, and I had someone helping, but there were not that many corrections. So whereas I've done such similar exercise a year plus ago, and it was certainly pretty bad, the way it wrote. I mean, better than me currently, but it was not good. So we're definitely measuring all the times, what if we have multilingual versions of these benchmarks, what's the gap, and then we close it by I don't know, like just if we observe it, we see it's big, then we can think about ways to use translation and filtering to get higher quality data that might not exist in all the different languages to cover more. We have lots of different things that kind of work. There is a profound different answer, which is more related to the Kalaman example, which is if we reach this level where the model can actually learn, you could imagine you train it in English purely, and you said, here are all the books. Here's all the data that is on the internet in different languages, all the books you might want to wish to read about the language, the properties, etc. Now I'll give you 2 weeks. Go and learn perfectly all these languages, because language is just a mapping of almost the same things. I mean, not all the languages use the same words, and obviously there are certain biases given geographics and so on, but that is a different way that would be very cool to improve. So if we say, we train the model, there is a gap. Imagine if I could just tell the model, okay, update your weights, do something, but now close this gap, go. This is the learning to learn, self-improvement loops that are gonna start happening in some way or another, and actually multilinguality is a cool one to explore in this way.
Bé,
right.
El meu dubte estava relacionat...
Where are you? Can you... Oh, okay.
El meu dubte està relacionat una mica amb la indústria general de la IA, perquè en l'avanç i a la búsqueda de models generals traiem una mica una separació entre el que fan potser empreses americanes com OpenAI, com Google, amb models més grans i que són molt costosos d'entrenar. Estava mirant abans que, per exemple, el ChatGPT està estimat que va costar uns 80 milions o més d'entrenar, i empreses xineses com DeepSeek o Moonlight que fan models més petits, a més open source, i costen molt més d'entrenar. I una mica per saber la teva opinió sobre com creus que evolucionarà, si creus que aquests models open source poden afectar a la rendibilitat, perquè al final aquestes empreses busquen rendibilitat, OpenAI i Google, o si creus que no afectaran i seguiran com en 2 zones diferents del mercat.
Yeah, great question. I mean, the advantage here is that the gap between open source and small models and big models is closing, because we also use them as teachers and so on. So there's a natural convergence, although sometimes the convergence is because the benchmark is fully solved. So it's like, okay, yeah, I mean, everyone is at 100, so that's the maximum. So that's not exactly convergence. But I am very positive that iterating, and in fact, internally, we do have a lot of compute, but it's definitely like a scarce resource as well at Google. Internally, to try certain ideas, you can't try them at scale, right? So we have a whole system of trying ideas at scales that are smaller than even the open source models that are very good for their size to discard or iterate on research. So we already are doing it. There's great open source models, and even Google has Gemma as well, which is on the smallest part of the family. So, and the gap and the capabilities, right? So you can imagine all of the 2 of them improve, and maybe the smaller ones will improve a bit faster because having access to some of the teaching of the large models. So you can certainly, I'm very hopeful that iterating on research ideas, especially at the basic level, is quite accessible from a compute point of view. And in fact, as I said, we're using it all the time ourselves as well.
Aquí, a l'Oriol. Moltes gràcies per tornar a l'UPC a donar una classe. La meva pregunta, abans has mencionat que una mica ens hem acabat les dades d'internet, però una mica aquests models generen noves dades que també van a internet i que potser també utilitzem per aprendre, i a més són dades que generen i que les persones també prenen d'aquestes dades que generen els models. Era per preguntar si veies algun risc en aquest cicle que es crea.
Yeah, great question. Data on the internet, and not even because of large language models, there's something that is actually targeted at Google to exploit the search ranking that is kind of, it's text, but it looks machine generated, and it basically tries to get results on the top of Google search, which is very valuable. So we've already seen, obviously, data that is machine-generated online pre-LLMs. Now it increases massively because these models, people post all the time about their experiences with the chatbots and so on. We are trying to explore what we call, and is called commonly synthetic data, to see how we can generate data, filter it by quality, and add it to the model for training. So we certainly do that, and we see some positive results. Most of what we see in these math-style results come through model generating answers and then picking, because we maybe know the reward, which is the answer we want to actually reinforce. So we do a bit of that already in post-training. So certainly we're exploring the idea, but because the quality of the data is important, we certainly need to, and we are trying to, and we have, of course, some ways to classify and detect data that is machine-generated. So if you take a snapshot of all the internet today, one of the common things we are going to try to do is which of these data is not human-generated, and at least discarding it is the safest thing to do, because the problem is distillation works well when the teacher is more powerful, but we're training, if we are learning from models that are less powerful and the distribution is a bit skewed, because of course humans don't write as well as some of these models as well, but at least it's a bit more spread. But once you have a single model that is very present and it's from a previous generation, you actually will downweight or be worse, and so the solution there is detection and filtering it out. But it's quite a cool topic to explore in both sides, for sure.
Hola, Oriol, aquí el galliner, aquí dalt.
Ah, okay, I see.
Gràcies per venir.
Great.
La pregunta era una mica més a nivell estratègic, des d'un punt de vista tècnic. És a dir, som conscients de que vens amb el barret de Gemini i de Google, i aquí tothom utilitzarà Gemini, no et preocupis. Però a nivell més, digue-li país, Catalunya, Espanya o europeu, sembla clar que requereix certa sobirania i no dependre de grans multinacionals, i aprofitant que estem aquí a l'UPC i al costat del supercomputador de Barcelona, hi ha hagut inversió, i ho sabem, som conscients tots aquí, d'entrenar models des de zero, des del preentrenament, a nivell, digue-li, català, espanyol o europeu. Costa de creure que podem mai competir models com els que tenim a Google o amb models open source que hagin pogut fer. Llavors la pregunta era si creus que té sentit seguir invertint en aquesta via, si s'hauria d'invertir en fer models més potser específics a nivell de salut, o si el que s'hauria d'invertir més és en la part més que has comentat al final de poder adaptar aquests models a casos d'ús específics, i que aquest és l'únic camí real que tenim per competir amb aquests models.
Great question. I mean, yeah, it's hard to, strategically, look, I guess time might not play in your favor, but of course, ideally, what we should do, and I think this, given the amount of expense, you would need a European-style initiative, but you want to be independent from an AI perspective, so probably the main asset is data centers, and main meaning also expensive and takes time to build. The BCC is a great example. I've been visiting over the years, and it's awesome to see. The first time I go, it's not yet clear that maybe GPUs are the way of the future. Of course, there's transformations of supercomputing being very CPU heavy and so on. But I see since the beginning at the scale that, of course, you can, given the funds, that very quickly there's a shift towards GPUs and deep learning, machine learning at BSc. So obviously, people in charge have done, in my opinion, the right choices, but there are constraints which are obvious in terms of capital and so on. But I was impressed. Even the last time I visited, I forgot the exact number of GPUs that were already active, but it was a decent number, of course, for how many people to use. But it's definitely you can do definitely important research at this level. And then, as I said, the democratization of AI through smaller models becoming almost as good, so you can iterate, as I was saying before, that's very important and positive. The other one is, Well, okay, yeah, open source. We can downstream and adapt the models to maybe be much better at the kinds of values that we want to add to the models in post-training and so on. It's a bit difficult to do that, but it's certainly possible. So I would say you need to be practical. So building on top of open source models that are great that we have that ability. Whether strategically you can build this, given the timelines, is not super clear, but there are efforts. I mean, Mistral, the CEO, was in my team, actually, Arthur. So, I mean, there are some European companies that have gotten a lot of investment as well, but it's tricky because if you think of the investment, where it comes from, it's not from the government. I mean, if it was the government, I mean, hopefully, okay, look, I mean, there's this budget, we just need to redirect it, but the capital is coming from venture capitalists, and the biggest firms, we know where they are, and then it's coming from the biggest multinationals, and also we know where they are. So it's difficult. Google and many companies do find useful to have, obviously, representation from different countries. DeepMind is in London, Demis is in London, and we try to influence internationally, not just biased on one point of view. And then the other, yeah, and so I think, yeah, but it's complicated. What would be the ultimate solution, which would be we should have our Google, our Microsoft, and so on in Europe. That didn't happen. That cannot happen in 1 or 2 years, probably. Although there's a lot of opportunity. I see a lot of startups as well. Barcelona is quite active. So maybe the catching up frontier, given the speed at which things are moving, also gets a bit more manageable. But yeah, you'll need to try you need to invest on all the above. I chatted with governments as well, Spanish and Catalan, lots of interest, trying to learn how to invest. The amounts of money that obviously are not the same as the ones that are privately raised in the US, and I guess China has other ways, but yeah, very, very important question. Thanks.
Sé que em matareu, perquè hi ha com a 8 o 10 paraules demanades, però l'agenda, us podeu imaginar, de l'Oriol és superconcentrada i ho hem de deixar aquí. Em sap molt de greu perquè hi ha moltes preguntes, segur que amb molt bones respostes. Teniu el seu X, el podeu contactar i trobarem la manera que torni, ara que tenim de professor a l'UPC, de tant en tant a poder fer-nos xerrada d'aquest estil. Li volem tornar a agrair, Oriol, d'acord? Per tant, un fort aplaudiment per la xerrada. Petit regal. Pots obrir. Li volíem fer un petit regal, d'acord? Es diu Gènesis, és un llibre de fotografia.
Molt bé,
Especulant sobre la idea de Gènesis en el passat i projectant la IA cap a futur. No sé si amb la nova AGI parlem d'un nou Gènesis.
Potser.
Caldrà veure.
Moltes gràcies. Gràcies. Merci, gràcies. Sí, gràcies.